Good evening. We will discuss about mechanical properties of solids, or we can call it as elasticity also, right? In this, our lecture plan will be in this way, that we take only previous year mains or NEET questions, which are little tricky and tough, okay? And we go through it, right? This is the basic revision plan. Let us continue. First and foremost thing, mechanical properties, we need to understand that few statements like stress, strain, deforming force, restoring force, all these things. The basics are already there in the YouTube. You can check it. If you want, you can understand the curve and all these things. So we know longitudinal stress is directly proportional to longitudinal strain, right? Now, stress can be written as force by area. The proportionality constant is Young's modulus in case of longitudinal, and strain will be change in length by original length. This is the basic formula that we are going to focus on right now. Okay. Then we think about bulk and rigidity modulus also. But anyway, we don't remember this and we don't deal with this in exam. We remember very simple that any string that we have can be replaced with a spring. Any string can be replaced with a spring. Remember, when we have string or rod, whatever it is, we have Young's modulus, right? So how do we deal? Observe carefully. In case of spring, we have spring constant K. We have spring constant K. In case of string, we have YA by L. So the role played by spring constant in case of spring will be by YA by L in case of string. Then observe change in length in case of string, and in case of spring, we take change in length as X. So once you remember this, everything is done. Observe, in this case, we know F is equal to Kx. We studied in case of spring. Same thing if you apply. F is equal to what is K? YA by L into X is what? Delta L. Check it, exactly same formula we are getting. Sir, then what is the advantage of memorizing these things instead of directly memorizing this formula? Logic is very simple. Now, after this, if at all they asked you calculate energy, right? Again, you need to remember another formula for energy, right? But if you remember like this, you don't need to worry about it because it's a simple spring. The potential energy of the spring is half Kx square, right? Same thing you can use. U is equal to half, what is K? YA by L into X. X is what? Tell me, delta L whole square. If at all you are interested, you can stop it here. Then you can go ahead with the problem solving. Small tricky things will be there. Something like this. Suppose if I take a spring, I can compress the spring, I can elongate the spring. Both cases, the force will be there. Okay. But I think you know it's obvious that in case of string, if you elongate, spring will elongate and elastic property comes into picture. But wait a minute. If you compress, generally in case of spring, it will get compressed. String, it will slack. Be careful. If it is a string, what happens? Tell me, it will slack. So some exceptional cases are there where maybe little bit tricky thing about elasticity will come into picture. Something like string is there. If I compress it, it won't get compressed. It will slack. But rod case, yeah, rod again behaves like spring. So these kind of small tricky things we need to understand. And after that, this is exclusive what? This is exclusive elasticity. They may link this elasticity to mechanics, maybe the circular motion or somewhere it is. We try to practice everything and we'll learn. So in any case, this 2 hours is the last practice I can say for you before exam, right? What you need to remember, spring, string or rod, both are same. K, YA by L, X, delta L over. This formula can be derived in examination hall. This formula also can be derived in examination hall. No need to worry about it. So first we solve very few simple, easy problems. The first question given in this worksheet, check it. That is simple concept. If the length of the wire is made double and radius is halved, okay, what happened to length? Length become double. I'll write like this. L is equal to 2L and radius is halved. R became what? Tell me. R by 2. Very good. Then the Young's modulus. What will happen to Young's modulus? Sir, it's simple proportionality. We have to take the formula. Wait a minute. Wait a minute. Concentrate here. Young's modulus is a proportionality constant. Remember, any proportionality constant in equation will never depend on any variable in the formula. So, Young's modulus depends only on the nature of the material or temperature or impurities added to the material. Apart from that, it doesn't depend on how long you take and all these things. So, Young's modulus, irrespective of whatever you do, it remains same. So, its straightforward concept is answer A. Answer A. Simple concept it is, okay? Question number 1. Right. Question number 2. It is simple what? Formula substitution. With ease you can get it. Solve question number 2. Quick, I want right answer. 100-meter long wire. Okay. Length is there. L is equal to 100 meters. Okay. Then having cross-sectional area. Area A is equal to 6.25 into 10 power minus 4 meters square. Thank God it is in meter square only. Good. Young's modulus Y. Y is equal to 10 power 10 Newton per meter square. Newton per meter square. Yeah, everything in SI is subjected to a load of 250. Okay. Force applied is 250. 250 Newton. Load of 250 means they applied force 250 Newton. Then the elongation will be. The question is delta L is equal to question mark. Okay. Easy to deal with simple formula substitution. Right. Anyway, you may take, sir, I can remember this formula. Very good, Kana. You can remember this formula. But I don't think in exam it is possible because after today, I don't think you will study elasticity at all. Hardly just before exam, you can see the formulas. I don't think you will have. And I'll tell you in terms of mains, definitely one question is there. On an average, one question per student. Means you will write exam 2 times, at least once you will get it. So you have to focus on this, right? In first attempt or second attempt, you will get it definitely on an average. So, right, if you want, you remember the formula or F is equal to Kx. K is what, tell me? Ya by L into X is what? Delta L. Simple. That implies delta L is equal to force into length by Ya. Now it's very simple. 250 into L. L is 100 meters by Y. Y is 10 power 10. My God. Denominator lo vandada. Okay. Area is 6.25 into 10 power minus 4. So if you simplify this, you will get there. It's easy to deal with simple formula substitution. All that. 250 by 6.25 will be around 40. Yeah. This will be 40 times. And then after this 10 power 10, 10 power minus 4, I can say 10 power minus 4 will be, this is 10 power 6. 6 goes to numerator. It will be 10 power minus 6. And 3 zeros are there. So it will be 4 into 10 power minus 3 meters. After this, it depends on what answer they gave. Okay, you check it. It is 10 power minus 3. Delta D, check it. Answer delta D. You have to practice. We are in revision. Fast and accurate. You have to. Both you have to get. You should not. You won't have 10 minutes, 12 minutes time. Maximum 2 minutes. You have to solve that set. Okay. Go ahead with 3. Question number 3. A force required to stretch a wire of cross-section 1 centimeter square to double the length will be. Okay, again, standard. F is equal to Ya by L into delta L. Is nothing but F is equal to Kx. That's how I remember. Okay, right. Force required that you need to calculate. Young's modulus is given. 2 into 10 power 11. 2 into 10 power 11. Area observe 1 centimeter square. 1 centimeter square means 10 power minus 4 centimeter square by length, and change in length is length itself because total length you have to make it double, right? So change in length is L itself. So LL gets cancelled. So the force required will be 2 into 10 power 7 Newton. In reality, it will not happen because you can't stretch a string to double the length generally. Metallic strings generally, before reach that stage, it will break, but we don't care. We take it and we solve, that's it. So answer is what? Answer is C. Answer is C. Fourth one. Question number 4. Young's modulus of material of wire A and B are in the ratio 1:4. Okay. I'll write Ya by Yb is equal to 1:4. Good. While the area of cross section 1:3. So area of A by area of B is equal to 1:3. Okay. If the same amount of load is applied to both the wires, that means what? Force same. Right? The elongation produced in the wires. Okay. What they want? The delta LA by delta LB. That's it. Is equal to question mark. So what we do in this case, simple proportionality we are taking. F is equal to YA by L into delta L. Observe, assume length of wires A and B are same. So L is same is given at the end. So L is same, F is same. Then if I write proportionality, delta L is directly proportional to 1 by YA. That implies delta LA by delta LB is equal to YB by YA and area B by area A. Sir, why? You know that it is inversely proportional. Inversely proportional is you have to take the reciprocal. That answer will be 4 by 1 into 3 by 1. 3 by 1. That is equal to 12 by 1. Answer is 12:1. So answer is B. Question number 5. Under the same load, wire A having length 5.0 meter and cross section 2.5 10 per minus 5 meters square stretches uniformly by the same amount as another wire of B of length 6.0 meter and cross section 3.0 10 per minus 5 meters square. The ratio of Young's modulus. So there again, it's a proportionality. Okay. So F is equal to Kx. K is what? YA by L into X is what? Delta L. Simple. Now concentrate under the same load. Same load means what? Force is same. Then what next is given? Check it. Having length. Length ratio is given. So no problem. They want Young's modulus ratio. Okay. And area. Check it. Area ratio is also given. But observe. Stretches uniformly by the same amount. That means delta L is same. That means in the formula, what we need to find, what we know is clear. So directly we can write the proportionality there. So Young's modulus, right? Young's modulus YA by YB is equal to LA by LB into area B by area A. Because if I write the proportionality, I should write it, I missed it in between. The proportionality formula is Y is proportional to L by A, right? Because these are constants. Whatever I rounded off is constant. So that's a proportionality formula. You can write, don't waste your time. That is equal to length ratio is given. Length ratio is given. Check it. Length ratio is 5:6. And area ratio reciprocally you have to take 3 into 10 power 5, 2.5 into 10 power 5. 3 by 2 because 10 power 5 gets cancelled. So if you observe this, it will be what? 1. So ratio is 1:1. Answer is what? Tell me. B. Question number 6. A wire of length L and radius R is clamped rigidly at one end. Good. When the other end of the wire is pulled by force F, the length increases by 5 centimeters. Fine. Another wire of same material, length 4L and radius 4R, is pulled by force 4F under the same conditions. Okay, increase in the length of the wire will be. Yeah, again, it is simple proportionality. F is equal to Kx. What is K? K is equal to YA by L. X is nothing but delta L. Right? Now concentrate here. Force is 4 times length, but area is not given. They gave radius. So you can outright like this. F is equal to Y into area. Area is pi r square by length L into delta L, right? Now pi is constant. Check it. Okay. Another wire of same material. So Y will be same. Remaining things we need to find. That implies proportionality will be delta L is directly proportional to F into L by R square. So delta L1 by delta L2 is equal to F1 by F2, L1 by L2, R2 by R1 whole square, because R is in denominator. That implies delta L1 is given. Delta L1 is 5 centimeters. Delta L2 we need to find. Force. Initially is F, finally is 4F. and initial length is L, final length is 4L. And observe radius, initial radius is R, final radius is 4R whole square. FF gets cancelled, these two gets cancelled, R gets cancelled. This is 4 into 4, 16. This is 4 square 16. The ratio is what? 1. So what is the final conclusion? Delta L2 is equal to 5 centimeters. So elongation will be same. Centimeter is already given. So answer is what? Tell me. 5. Numerical it is. Answer is 5. Question number 7. A force is applied on steel wire A, rigidly clamped at one end. As a result, elongation in the wire is 0.2. If the same force applied on another wire B of double the length and diameter 2.4 times, okay, then wire A, elongation of the wire B will be, okay, fine. It's again proportionality. F is equal to Kx, where K is Ya by L into delta L. But observe carefully here, diameter is given. So F is equal to Y into pi R square. Pi into R is what? D square by 4. L into delta L. This is the formula. Pi is constant. Same force given there. Check it. Okay. Okay. Wires having uniform circular cross section. That's fine. Both are given as steel wires. Check it. So Y is same. 4 obviously same. That's it. What they want? The elongation, the ratio they want. That implies delta L is directly proportional to L by D square. This is the proportionality. Check it. So we can write like this. Delta L by delta, okay, L1 by L2, AB. LA by LB is equal to LA by LB into DB by DA whole square. If you substitute the data, elongation in the first wire will be 0.2 millimeter, 0.2 millimeter by elongation in B. We don't know, we have to calculate length, double the length. So length of A is L, length of B is 2L. And see, if you have enough practice, you don't write L and 2L. Simply you'll cancel, directly write 1 by 2. That's also good. And diameter is 2.4 times. So initial diameter, the initial diameter of A is D, diameter B is 2.4 D, and it is whole square. So if you cancel D and these two, it's a matter of simple calculation. Delta LB is equal to 0.069 will come. So you can write 6.944 something. 6.9, 2-digit decimal place into 10 power minus 2. Minus 2 millimeter. So answer will be D. Little bit of complexity, little complexity is then the calculation, but you need to handle it. Okay, next one. Question number 8. This one is good. And up to now, we just solved few questions which are very easy relatively because it's simple proportionality and formula. And remember, those questions are there. I'm not telling you just for sake of giving questions. I haven't created those questions. They are already there in the previous mains. So some will be very easy. Some will be little tricky. That's it. So this one, whenever graph is given, somehow you have to find the equation. Okay. You have to check what is on x-axis, what is on y-axis. Okay. So first and foremost thing, equation is clear for us. F is equal to kx. Instead of k, we write Ya by L into delta L. X is delta L. Okay. And remember, some students directly say, I don't use delta L, I'll use X. Who cares? No problem. You can use it. You need to observe these things little carefully. So on x-axis, wire length. Okay. X-axis, they took wire length, L, fine. But observe, on y-axis, it is not load. It is not force or something. It is given as, check it, extension by load. Delta L is extension. By load means load is nothing but the force you apply. Okay. So you have to rearrange it like this. Delta L by F is equal to, delta L by F is equal to L by Ya. Sir, why? Concentrate. On y-axis, we have extension by load, right? So extension by load, this is y-axis. If you compare this with equation y is equal to, remember this is capital Y, this is small y. Small y is mathematics variable y, capital Y is Young's modulus. And small l is the length, so that is x I can take by ya. Or more perfectly speaking, it's clearly given that it's a straight line. So I can write like this. It's in the form of y is equal to mx plus c. M into x plus c is 0 because passing through the origin. And observe perfectly the equation is matching. So this entire value is y, perfect. This value is x, correct. Now you can, with ease, you can conclude the slope m is equal to 1 by ya, right? They want y. So very simple. If you want y, you can write like this: 1 by slope into area over. What is slope? See, for a straight line, slope is always constant. So I'll calculate slope here. You can take anything. You can take this length and this length. You can calculate slope, or I prefer this 1 and 4. Calculation will be easy. So delta y is 1. Check it. Delta y is 1. Delta x is 4, right? So delta y is 1. Delta x is 4. But be careful. Here 10 power minus 5 is there. So you have to write 10 power minus 5. That's the slope. So it will be 10 power minus 4, 5 by 4 into area. What is cross-sectional area? 2 millimeter square. Okay. 2 into millimeter means 10 power minus 3 millimeter. Millimeter square means 10 power minus 6. So if you simplify this, you will get the answer. 2 how many times? 2 times. So this 2 go to numerator, and 10 power minus 5 minus 6 is minus 11. So finally, what is the Young's modulus? Young's modulus y is equal to, so answer is 2. Question number 9. A steel wire of length 3.2 meter, Young's modulus is given there. And copper wire of length 4.4 meter, again Young's modulus is given. Both of radius 1.5 millimeter are connected end to end. So what is this end-to-end connection? What is the key point in this? Observe, we need to understand that we take a rigid support, ceiling is there, ceiling. You can see that I made the ceiling here. And then I'll connect both the wires, okay? Right. Check it, they're connected end to end. End of the first wire is connected to end of the other wire, okay? Then stretched by a load. Now concentrate. The upper part, let us take it as steel. The lower part is copper. And some force is being applied. What is the key idea in this case is that the force must be same in steel and copper. End-to-end connection, the key idea that you need to understand is the tension will be same in this and this because you're applying force F. Sir, what about mass of the wire? That's a good question. In reality, unless specified, we generally neglect the mass of the wires. They're very thin wires, negligible mass will be there. So we neglect it, right? Up to now, we are neglecting, actually speaking. Okay. Anyway, we neglect it. So tension will be same in these two. So what's the final conclusion? Instead of giving, both are stretched by same, what? Same force. They said like this, that force FB is applied and they're connected end to end. Now concentrate, if steel elongated by delta X and this also elongated by delta L1, delta L2, then total will be delta L1 plus delta L2. Anyway, let us do one thing. Let us give the number to it. Steel is 1, copper is 2. Okay, let us continue. Now, formula F is equal to YA by L into delta L. I think it is also very close to proportionality. We'll go ahead with it and observe what is the key points we need to know. That is, force is same. Very good. Cross-section area is also same. That implies what? Tell me. Delta L is directly proportional to L by Y. That implies delta L1 by delta L2 is equal to L1 by L2 into Y2 by Y1, right? So L1 by L2. I took copper as second, right? Yeah, fine. L1 by L2 is 3.2 meters by 4.4. No need to worry about it. Into Y2. Young's modulus of copper will be 1.1 by 2.0. 4 is to 10. So you have to divide in the ratio of what? Tell me. 4 is to 10. So now is equal to 4 millimeter. Perfect. The first one will get elongated by 4 millimeter, right? So now we'll continue with it. The force they want, F is equal to Young's modulus of steel, 2.0 into 10 power 11. Area. What is area? The radius is given, pi r square. Pi is 22 by 7. Pi r square. What is r? Radius is 1.4 millimeter. 1.4 into 10 power minus 3 whole square. Yeah, I got the area there. Y is equal to, sorry, F is equal to YA by L. L is 3.2 into delta L. Delta L is 4 millimeter. 4 into 10 power minus 3. Lengthy calculation. If you go through it, you will get answer 154. 154. So answer is D. Question number 10. What is the trick in this? Not much. Most of you can pick it up. Anyway, I'll explain that. A wire of length L is hanging from fixed support. Okay, right, good. The length changes to L1 and L2 when masses 1 kg and 2 kg are suspended. Length changes to L1. What is the meaning of it? Observe, when you take the case of a object or maybe a string, let us take the previous example, only one wire I'm taking, okay, is connected. It has some initial length L. Let us take it as capital L. When you subject it to load, what happens? The length will increase. I'm making the diagram there. So whatever is, this is delta L, change in length. But remember, new length will be L1 they gave. So what is the meaning of it? Let us take change in length is delta L1. So I can say like this. L1 is equal to L plus delta L1. Similarly, L2 is equal to L plus delta L2. Because our mathematics is based on delta L. But they gave what? L, extended length. Not extension, the final length after extension. So this is a small trick that you need to know, that's it. So let us write the formula. F is equal to Kx, K is Ya by L into delta L. That implies delta L is equal to F into L by Ya. Now substitute the value there. Then I can write like this. L1 is equal to L plus F1 L by Ya, and L2 is equal to L plus F2 L by Ya. That's it. Now observe this, that F1, F2 is given. Now ultimately you have to do what? Simple rearrangement of these things. So what is F1? F1 is 1 kg. So what I do is that I replace this F1 with 1g. 1g. So simple 1, I'll drop it. And L2, I replace F2 with what? 2g. 2g. Now you can do one thing. You can multiply this entire equation with 2. And you can take this minus this. Reason is you want to eliminate this point, this term. No? The term is not there, check it. So I can say like this. 2L1 minus L2 is equal to 2L minus L. This minus this equal to this minus this. And these two gets cancelled. That's it. That implies what? L is equal to 2L1 minus L2. Okay. Answer will be C. What you need to learn in this question? In this question, very simple. Remember, they haven't given elongation. They gave length after elongation. The total length they gave. That small point you need to know. That's nothing else. Okay. In the previous question, when two strings are connected in end to end means what? They'll have same tension. And when they're hanged to the ceiling, something like that, generally we neglect the mass of it unless we need to focus on it. Okay. There are some questions where we need to focus. We'll discuss that also. Go ahead with question number 11. Question number 11, right? This is a special case. I told you, na? Generally we neglect the mass of the string, but check it. A uniform heavy rod, it's not a string, it's heavy rod, 20 kg. Rod itself is 20 kg. Cross-section area 0.4 meter square and length is 220 meter, is hanging from a fixed support. Neglecting lateral contraction, that means when you increase the length, the area will decrease. The elongation in the rod due to its own weight is, okay. Two ways are there to deal with. First one is that you need to go through little bit lengthy integration, okay, or else simply you remember a shortcut, right? One simple shortcut you have to remember. That's enough. Sir, tell me how to deal with the lengthy integration. Simple logic. You observe carefully. In this case, as the rod is 20 kg and entire 20 is not at the lowermost point. 20 is completely distributed here. Continuous variation is there. Suppose if I take midpoint, right? So at midpoint, below will be 10 kg. So 10 into G, 100 Newton tension will be there. If I take the topmost point, it will be entire 20 kg has to be there. So 200 Newton will be there. Exactly midpoint of these two, if I take, it will be 150 Newton. And if I take this one, it will be 50 Newton. It will be 50 Newton. And lowermost point, 0 Newton. That means lowermost point doesn't have any force. So lowermost segment will not elongate at all. At this point, if you take it, the segment will be elongated by 50 Newton force, 100 Newton force, 150. So force is continuously changing. That's a problem there. So elongation is continuously changing. So it elongates more in this region, less in this region. That's a feel if you want to understand. Okay. I remove all these things. So what I do is that, I take all these things, I remove it. Yeah. Now observe, I take some random distance, this length L. There I take very small length dl. Now this dl is loaded with remaining part. So you can write the remaining part is L minus small l. But anyway, if you have good sense, you will understand taking like that, and it creates a bit, what we can say, lengthy integration. The best option is take length from the lowermost point. This is L. Now the mass will be proportional to L only, the mass which is below. So L and dl. Now concentrate here. What is the mass below? You have to calculate. So total mass by total length is equal to mass below is small m, let us take it, by small, the length will be L, right? That implies the tension T is nothing but mg, where the mass is, which is below here, it has to hold. So tension T is equal to mg, that is equal to capital Mg by capital L into small l, right? So tension is a variable proportional to L. Now, because of this tension, if you take F is equal to YA by L into delta L, this formula cannot be applicable because it's not applicable because it's not for a uniform and all these things. So what we do is that we take the small element, check it, the small element dl length I take, that dl length will elongate by dx. Small element dl elongates by dx. That's what the key idea. That is equal to, what is F? Mg by capital L into small l, where capital L is total length, is equal to y into a into length. What is the initial length? dl, check it. Okay. And delta L is what? Change in length. Change in length is dx. I repeat, dl length element elongate by dx. That's a key idea. Now take dl on the other side, then integrate. It will be mg by lya into l dl integrate is equal to integral dx. Integral dx will give you addition of small elongations of each piece. So that is total elongation. Okay. That implies mg by LYA. Integral DL is what? Tell me. L square by 2. L value will be 0 to capital L is equal to integral dx is what? Tell me. Integral dx is delta x. Delta x is total elongation. That's what they want, delta x. So delta x total elongation is equal to, if I substitute the value, it's L square by 2 and this L and that L gets cancelled. So direct step I write mgl by 2ya. This is the thing. Sir, this one you expect me to do in examination? In a way, yes. This is the first thing. Sir, any shortcut, just simply remember, it is a kind of wrong method, but you'll get right answer. When you have a body which is elongating because of its own weight, simply take what? Center of mass, problem solved. That's it. So what is the value? F is equal to, what is that? YA by L, YA by L into delta L, right? That implies delta L is equal to YA by what? No, sorry, delta L is equal to, missed it. F is what? mg L, total length by 2, because I have to take center of mass. Okay, into YA. If you take the center of mass length, problem solved. So I do know students who remember this and solve this question if it comes in examination. Okay. Sir, actually there is a lengthy integration. My recommendation is this integration doesn't have further applications. So you can blindly remember this, right? Take effective length as center of mass length, khel khatam. That's it. Okay, question number 11. Go ahead with. Actually, question number 12 is simple previous one only. Same thing. And that too, it is given August 2021, check it. And other one is July 2022, the previous question. So I recommend you to remember center of mass length. Okay. So a uniform rod of weight 10 kg, right? So mg is equal to, F is equal to YA by L. L is L by 2 into delta L, right? That's it. Why I'm taking L by 2? Center mass length. Own weight on the center mass. Okay. So that implies delta L is equal to mg. What is m? 10. Weight. It is not, mass is not 10. The weight is 10. 10 kg meter per second square is nothing but what? 10 Newton. Oh, they gave mg value. Little bit careful here. Multiply with 10 panna, answer tapporum. 10 kg is not mass. 10 kg meter per second square. That means what? 10 Newton. They gave force. Okay. mg into L. Length is 20 centimeter. 20 into 10 power minus 2. Anyway, by 2 we have to take. Directly I take 10. mg L by 2 by YA. Young's modulus 2 into 10 power 11 into area 100 centimeter square. 100 into centimeter square will be 10 power minus 4. Now it's a matter. 10 power 4 will be plus 7 it is. Plus 7 will go to numerator. Oh wait, these two gets cancelled. Okay. Plus 7, plus 8, plus 9. 1 by 2. So it will be 0.5 into 10 power minus 9 or 5 into 10 power minus 10 meters. Yes, units, na? Yes. So answer is B. Good. Question number 13. If the ratio of lengths, radii and X modulus of the steel and brass wires are shown in the figure, ABC respectively, corresponding ratio of increase in their lengths. It is proportionality only. A lot small trick is there. Observe. F is equal to Kx. K is nothing but YA by L into delta L. That's fine. Right? Check it. They gave ratio of lengths. They gave. So that no problem at all. Radii is given means area is we can find. And Young's modulus is given. But force ratio, it's not directly given. They're checking your skill in mechanics also. So new topic is being added. Here it is addition of mechanics, right? Up to now we are studying what? Normal, Young's modulus and proportionality. Now they introduce something. Now observe carefully. This brass wire has to take the load of 2 mg. But the steel wire has to take the load of mg. Tappu. Mg plus 2 mg. 3 mg it has to take. So observe, I'll take steel as 1. I'll take steel as 1 and brass as what? Tell me? 2. Now, if I take that way, it will be F1 by F. Okay, let me write the formula perfectly because radius ratio is given. F is equal to Y into pi r square. Oh, sorry, small r square by L into delta L. Now, observe, they gave the ratio of radii, ratio of length as length, and ratio of force is also given in the diagram. They want this one. Only thing which is constant is pi. No problem. We know completely about equation. We can deal. Now, if I write the proportionality equation, the proportionality equation will be like this. Delta L is directly proportional to F into L by Y into R square. Good. That's it. After that, we have to go for the standard. Delta L1 by delta L2 is equal to F1 by F2, L1 by L2, Y2 by Y1, R2 by R1 whole square. I think job done. F1 by F2. F1 is 3 mg. F2 is 2 mg. This is the point you need to understand. This you will get it only by mechanics. So the steel wire has to take the load of 3 mg. That's a key idea. L1 by 2. The ratio of length is A. This is A. Ratio of radii is B. But here I need inverse ratio. So 1 by B square into ratio of Young's modulus is C. So it will be C. Now what I can do, I can cancel these two. Increase in length is corresponding ratio. Wait. Ratio of delta L1 or delta L2? Which one we have to take? Steel to brass. So no problem. 1 to 2. No issues. Steel to brass is given. No, perfect it is. That implies what? They want delta L1 by delta L2 only. That is equal to 3AC by 2B square. 3AC by 2B square. Wait. Young's modulus is inverse ratio. I did a mistake. Lucky that answer is not there, right? So Young's modulus is not C, 1 by C, right? So 3A by 2B square C. Answer is C, Charlie. Answer is C. This is how you need to deal with. Okay. So mechanics introduction is a bit more complex here, right? Makes it little complex. Question number 14. It is not the problem of Young's modulus. The formula is very easy, right? The formula for Young's modulus is F is equal to Kx, like spring. But K is what? Ya by L into delta L. Yeah, fine. So the stress produced. Wait. Oh, stress. Okay. Unnecessary going for this, right? Too much of practice. That's a problem. But stress is what? Force by area. That's it. So what is the force in the string? Very simple. Force in the string is nothing but tension. So if you can calculate the force is nothing but tension, and area is given there, then I think it's job done. So personally, I feel elasticity will give you only one formula. What is that? Stress is equal to force by area. That's it. After that, everything is what? Tell me, mechanics. You have to find tension in it, right? So standard stuff. Quickly, I'll find the thing by using what? Free body diagram. Okay. Wait. Downward mg, small mg, and other one downward will be capital mg. And capital mg is 2m. Na? Directly we use. Why should we write in detail? Remember, I'm teacher. I need to explain. That's why I'm writing in detail. If you can minimize the calculation, try to minimize as much as possible. Okay. Same tension T. Yeah, we need to indicate the mass there, right? Yeah, mass as a particle. Free body diagram. Good. Right, what next? We got that. So definitely 2 mg will go down, this mg will go up. So net force is equal to 2 mg minus T is equal to 2 ma. And then T minus mg is equal to ma. But what I do is that I will multiply entire the equation with 2. Now these two I can equate. I can eliminate a with ease. That implies 2 mg minus T is equal to 2T minus 2 mg. So if you rearrange them, that implies 4 mg by 3 is equal to T. Yeah, if you want stress by area A. So answer is 4 mg by 3A. Answer Bravo B. Yeah, that's it. So by practicing, you learn small things. Okay, tension in the string will be the force which will cause stress and all these things. That's what you need to. Okay, right. Question number 15. I told you now that most of the times what happens is that this the concept of YL by A, F is equal to YA by L into delta L will be connected to something in what? Mechanics. So what they did, they took it to the other planet. When they took it to the other planet in question number 15, read the question. Other planet means what? G will change. I thought like when I read the question, I thought like, okay, they won't give G value directly. They may say like this, G is equal to, you know very well the formula for G capital M by R square, right? They say mass is double, radius something, right? So that it will be a little bit what? Tough. But even they haven't done that. Directly they gave on the other planet, sorry, G is G by 4. Directly they gave. So I personally feel that what is the effect of adding new topic, gravity in this? Nothing. There is no effect. Instead of mg, you have to take mg by 4. All that. So anyway, let us continue. F is equal to YA by L into delta L. That is what F is equal to mg by 4. So mass is 4 kg. G is 10 by 4. Good. 4 gets cancelled. Is equal to Young's modulus 2 into 10 power 11 into area. Area is given. Cross section 3 millimeter square. 3 into millimeter means 10 power minus 3. Square means 10 power minus 6 by L. Okay. What is length L? Length is given. 6 meters is given. 6. Good. Into delta L. Yeah. 2, 3s are 6 gets cancelled. This will be 5 times 10 power 5. So if I take 10 power 5 on the other side, delta L, that implies delta L is equal to 10 into 10 power minus 5 or 10 power minus 4. 10 power minus 4 means meters it is 0.1 millimeter. Yeah, answer is D. Answer D, 15th one. Perfect. A string of cross section 4 millimeter square and length 0.5 is connected with a rigid body of mass 2 kg and body is rotated in a vertical circular path. You have to be a little careful here. It's a vertical circular path. That's a problem. Okay. Student miss out that point. Okay. So what they do, I'll tell you. The body acquires some velocity is given. Okay. Strain produced. So strain is what? Tell me, delta L by L. Strain. Anyway, strain can be calculated by using this also. Instead of delta L by L, I can do one thing. I'll take F is equal to Kx. K is what? Ya by L into delta L. So I want delta L by L strain, right? That is equal to F by Ya. And Y is given, area is also given there. It's not a problem. Only thing is that F. Sir, it's moving circular path. So F is equal to mv square by R. mv square by R. That's a mistake. Sir, why F is equal to mv square by R mistake? I appreciate your way that you are applying it, but you are missing out a key point there. What is that? We treat it as a particle, fine, no problem. Okay. Net force towards center is equal to mv square by R. It is not force is equal to mv square by R. Net force towards center is equal to mv square by R. So towards center is T. And in a vertical circular motion, it's clearly given, check it. It's clearly given that it's in a vertical circular motion. So downward mg will be there. I think color code, our color code is mg is blue color, right? Yeah, good. Blue color. No, not this blue. This blue, yeah. mg. So 1 minute, I think it's not straight. No, it's not straight. Diagram itself is slightly off. 1 minute. Good. Tension T will be here. Good. Yeah. Now, net force towards center is mv square by R. So T minus mg is equal to mv square by R. This is wrong. That's a mistake I think he's expecting. Now, if you solve it, T is equal to mg plus mv square by R. Now, what is the mass? 2 kg. Right? Okay. 2 into G. G is given 10, good. Plus 2 into, what is the velocity? 5. 5 square is 25 by R. R is radius. Radius is 0.5. 0.5. 0.5 4 times. 4 into 25, 100 or 120. So tension T is equal to 120. So multiple cases are possible. Student may take T is equal to mg. If you take T is equal to mg, then you will get 20. T is equal to mv square by R, you get 100. But in reality, it is 120. After this is purely mathematics. That's it. So delta L by L, the strain will be equal to 120 by Young's modulus. Young's modulus is 10 power 11 into what? Area. Cross-sectional area 4 millimeter square. 4 into 10 power minus millimeter means 10 power minus 6. So observe 10 power 6. It will be 10 power 5. 4 how many times? 30 times. 10 power plus 5 will minus 5. 3 into 10 power minus 4. No. 10 power 5 only they want, right? Check it. They want into 10 power 5. So 30 into 10 power minus 5. So answer is 30. So numerical, no? It is. So answer is 30 here. You have to put 30. Good question. It will teach you something. And remember, the toughness is because of 2 things are being added there. What is that? Elasticity and mechanics. Question number 17. Anyway, I'll teach you a new concept here. Right? Breaking stress. What is this and all? See, if you have a thread, if you want to break it, what to do? Sir, apply force. Right? So you feel by applying force, it will break. Absolutely right. It will break. But observe carefully. If I take a string, by applying 10 Newton, if I can break it. If I take 2 strings side by side, if I twine them, or maybe keep them side by side, or maybe 3 strings if I take, the same 10 Newton, it won't break. You need 3 strings means 30 Newton you need. So remember that instead of having 3 strings, I can say like this. There is a string which will break for 10 Newton, and there is another string which has thickness 3 times. Thickness 3 times. Thickness is that no area 3 times. So if the area of this is A, this will be 3A. Now, thick string will not break for 10. It breaks for more. So what is the key point here is that try to understand. Although, yes, strings will break because of application of force, but my statement is like this. Just remember, strings break because of stress. This statement will emphasize on, be careful, the breaking is decided by stress, not by force. If you double the radius, area will be 4 times, and you need to apply 4 times more force to break it. Or else, if you don't want this statement, you can take it like this. That is, for a given material, breaking stress is constant. So what is the key point you need to get in this is that very simple, that you leave it. This one, you can ignore this if you want. You can, breaking stress is constant means what? If you take 2 different wires, okay, of same material and different thickness or maybe radius or area, you take a cross-section area, they won't break for same force, but they break for same stress. So stress is the key thing here. For breaking stress is the key thing. Okay. So just that's what you need to remember. This extra thing you have to add, apart from that F is equal to Kx, right? That thing. Now we can continue. Area of a cross section of a rope used to lift a load by crane. Okay. Something 2.5 10 power minus 4 meters square. The maximum lifting capacity is 10 metric tons. Metric means 10 power 3. Right? Right. To increase lifting capacity by crane to 25 metric tons. Okay. So the core idea is that stress is same, right? So first case, second case, stress is same. Right. So what is the first case? Force is 10 metric tons. F1 by F2 is equal to, observe, concentrate here. Stress is same. Stress is force by area. When stress is same, it's simple proportionality. F is proportional to A. F is directly proportional to A. That implies what? F1 by F2 is equal to A1 by A2. That's it. A1 by A2. So A1 is 2.5 into 10 power minus 4 meter square by area of this is A, we have to calculate. Good. Keep it as it is. What's there in it? Direct, we can use that. Stress is same. Yeah. Now, perfect. That implies area A is equal to 2.5 into 25 into 10 power minus 4 by 10. So it will be 2.5 into 25 will be 62.5, right? Yeah. 62.5 into 10 power minus 5. Wait, 4 is given. So 6.25. Correct. 6.25 into 10 power minus 4. Answer is alpha A. Remember, strings will break because of stress or breaking stress for a given material is fixed. Area changes, force changes. Okay, so what is core thing? Stress. Question number 18, observe. A metal of wire 0.5 meter and cross-sectional area 10 power minus 4 meter square has breaking stress 5 into 10 power 8 Newton meter square. Good. A block of 10 kg is attached to one end and rotating in a horizontal circle. Sir, circular motion. Yes, we already solved it. Be careful. When we solved it, it is, check it. It is given clearly vertical circle. Now it is given what? Horizontal circle. When it is moving in the horizontal circle, observe, mg won't be away from the center. It is perpendicular to the radius. Mg will be into the plane, I can say. So it is not towards center or away from center. So in this case, you have to write like this. T is equal to mv square by r. T is equal to mv square by same statement. And that the previous question that I showed it to you, there it is wrong. That implies, wait a minute, force is required. You know very well. Stress is equal to force by area. So tension T must be equal to stress into area. Stress into area. More perfectly speaking, we are going for breaking. So breaking stress into area is equal to mv square by r. That's it. We got the key equation. We get the answer. That's it. That implies breaking stress is 5 into 10 power 8 into cross-sectional area 10 power minus 4 meter square, everything good, mass 10 kg into maximum linear velocity is v square by length 0.5. 1 by 2 I take. Leave it. Keep it as 0.5. Now, if it's a matter of simplification, v is equal to, this will be, let us cancel, this will be 4 times. And this 4, this 10 will be, it'll be 3 times. So this 0.5 will go there. 0.5 into 5 is 2.5. Or I'll write 25 into 10 power 2 under root, because square is there, square root it will be. So velocity v is equal to 50 meters per second. Meter per second is already given. So answer is 50. 19th one, 2 blocks of mass 3 kg, 5 kg are connected by a metal wire. Good. Going over the pulley. The breaking stress is 24 by pi into 10 power 2 Newton per meter square. Good. What is the minimum radius of the wire? See, I think you can understand. Here, instead of using Young's modulus and F is equal to YA by L, they're using breaking stress. So finally, we have 2 segments there. One segment is what? F is equal to Kx. That is F is equal to YA by L. I'll write it. F is equal to YA by L into delta L. They may ask proportionality or they may link force with what? Mechanics. That's the first thing. Second thing is breaking stress. Right? Those are 2 things. And they can link this also to mechanics. You know? So we already saw this one linked to mechanics, previous segment. Now breaking stress also, they're linking it what? Tell me. Mechanics. Let us see how we can make it. Sorry. Yeah. So let us start with it. Standard stuff. I'll do one thing. I'll take free body diagram from the previous segment. Directly I'll copy it. This is 50. This is what? Tell me 30. So I solve it like 50 will go down. 50 minus t is equal to 5a. And t minus 30 is equal to 3a. Simply add them. It will be 20 is equal to 8a. That implies a is equal to 20 by 8. 2.5 meter per second square. Now, put this value here, you'll get t. P is equal to 30 plus 3 into 2.5, 7.5. So it will be 37.5 Newton. Good. So that breaking stress is equal to force by area. That force is nothing but tension T. So breaking stress is 24 by pi into 10 power 2 is equal to force. Force is 37.5. I think if I keep it as 75 by 2 is good. It's okay, fine. By area. Area is pi r square. Minimum radius. That's what we need to find, r square. Good. Pi gets cancelled here. That implies, this also implies only from the previous formula we got it now. So good. R is equal to 75 by 2. 37.5, I take it as 75 by 2. And it will be into, oh no, keep it as it is. Denominator 24 into 10. Good. That's it. Now cancel. 3 times, this is 8 times, this is 25 times. 325 is that, right? Yeah. Now this is 16. It will be 25 is 25 under root will be 5. 16 will be 4 into 10 power minus 1. So 5 by 4 is 1.25 to 10 into 10 power minus 1. Therefore, R is equal to 0.125 or 12.5 centimeters. So answer is Charlie C. Let me check the answer. Perfect. 17C. Right. Question number 20. I think you can understand this logic that the string here has to take the load of these 3. The string here has to take the load of these 2. Pan has to take only this load. That's a key idea. Mechanics. W1 and W2 are made up of same material. So Young's modulus is same material. Na? Good. Breaking stress. Okay. Breaking stress is equal to 1.25 into 10 power 9 Newton per meter square. Good. And of course, both are made up of same material and breaking stress will be same for both. W1, W2 cross-section area. Oh, given. So A1 by A2, let us take the ratio, will be 8 by 4. 2. Maybe ratio may not be useful. We'll see. Masses of 20 kg and 10 kg hung from the shown figure. The maximum mass that can be placed in the pan without breaking the wire is. Now try to understand. We don't know whether this will break or this will break. Right? So blunt method is that you assume this will break and calculate the maximum. You assume this will break and calculate the maximum. Right? That's it. That's a one way of dealing with it. Yeah, we continue. W1, W2 is 30 into G300. Right. I'm going for the first one. This string. Breaking stress 1.25 into 10 power 9 is equal to force by area. Force is 20 plus 10, 30. 30 into G is 10. Na? So 300 plus mass in the pan is M or M1. Let us take it into G is 10. This is a force by area. What is area? W1 is 8 into 10 power minus 7. That implies 8 into 10 power minus 7 will go there. So 8 into 1.25 will be 10, right? Yeah, 10. 10 into 10 power minus 7. This will go there. 10 to 10 power minus 7. This will be 100, right? Yeah, 100 is equal to 300 plus 10 M1. My God. No, 1000 it is, not 100, 1000. Check it. So that implies M1 is equal to, this is 1000, sorry. Yeah, 1000 by 300. By minus 300 is 700. 700 by 10 is 70. 70 kg. This is the one possible answer. But wait a minute, before it reaches 70, it may break, na? So we have to go for the second one also. This is the first one. That means what is the, assuming second won't break, or if at all first, if this wire breaks, then this is the thing. Let us go for the second one. Let us take the second wire. What is the min required? That one. Same value. Breaking stress 1.25 into 10 power 9 is equal to, in this case, 100 plus mass is M2 assume, into G is 10, by cross-section area is 4. 4 into 10 power minus 7. Okay. Now 4 into 1.25 will be 5, right? Yeah, 5. So if I simplify this, that implies 5 into 10 power minus 7 into 10 power 9. I'm writing in detail because previous case I did a silly mistake, na? 10 M2. So it will be 10 power 9. This will be 10 power 200, 500. 500 minus 100 is 500 minus 100. 100 will come like this. So 400. 400 by 10 is 40. M2 is equal to 40 kg. Oh, now it will break for 40 only, na? Answer is 40 kg. Sorry, for 40 kg. Kg is given, so answer is 40, numerical. So what is the conclusion? If this holds, the second wire holds, assume, this will break at 70. If you add 70 kg, it will break. But before you add 70, 40 itself, it will break. Na? That's ideal. Good.